Hello everyone, in this video we will be discussing the chemical reactions of alkanes. Now according to our syllabus for the academic session 2020, the chemical reactions of alkanes have been reduced and we will be studying only three of them, that is isomerization reaction, aromatization and the reaction with steam. Therefore let's check out the first chemical reaction, that is isomerization reaction. Now, what is isomerization reaction? Now, the process of conversion of one isomer to another isomer is known as isomerization reaction. Now, here, N-alkanes are converted into its isomer in the process of isomerization reaction. Therefore, in this type of reaction, an isomer is converted into another isomer. Therefore, let's check an example here. CH2, CH2. Now, this is our straight chain and butane 1, 2, 3, 4. 4 carbon atoms, therefore it will be butane. Straight chain isomer. This is our N-butane. Now, isomerization reaction, the catalyst used is aluminium AlCl3 aluminum chloride plus HCl concentrated on heating. When N-butane on heating with aluminum chloride and concentrated hydrochloric acid, we will be getting a branch chain isomer, that is, this will be our isobutane. Now, this is the isomerization reaction for when N-butane reacts with aluminum chloride is a Lewis acid and HCl is a strong acid. Now, the reaction of these two, it isomerizes the N-butane to isobutane. Now, another type of example is for this type of isomerization reaction is that less branch chain alkanes are converted into more branch chain alkanes. That is, let's take an example here. This is a branch chain alkane 1, 2, 3, 4 and 5. So straight chain, the longest carbon chain, we will be selecting the longest carbon chain, and therefore in the second carbon we have our methyl group. Therefore it would be 2 methyl 1, 2, 3, 4 and 5 carbon atoms. Therefore it will be pentane, 2 methyl pentane. When it reacts with aluminum chloride and HCl, a Lewis acid and a strong acid, on heating we'll be getting, for this part it would remain the same, and we'll be getting a lesser branch chain to a more branch chain. Therefore this is a 1 carbon atom, 2, 3 and 4. Therefore on carbon number 2 and 3 we have our methyl groups. Therefore it would be 2, 3 di means 2, 3 di methyl, 4 carbon atoms. Therefore it would be butane. Now this is the isomerization reaction, the chemical reaction of alkanes. Now let's check out the second one. The second one is aromatization reaction. Now what is aromatization reaction? Aromatization reaction means the word itself says that it should be an aromatic compound. Therefore here, when carbon atoms CnH2n plus 2, this is our general formula for alkanes. Now the carbon atom should be greater or equal to 6. The carbon number greater or equal to 6. When it aromatizes alkanes with carbon number greater or equal to 6 aromatizes, we get here an aromatic compound, and we will be getting here an aromatic compound. Therefore now this is the conversion of aliphatic compounds to aromatic compounds. Aliphatic compounds to and aromatic compounds means typically it would be our benzene ring. Therefore the alkanes having carbon number 6 to 10 or more than that carbon atoms, they are converted to benzene or its derivatives at high temperature and in the presence of a catalyst. Therefore now let's check out the chemical reaction of this type of the aromatization reaction. CH3, CH2, this is a straight chain alkane. This is a straight chain alkane. It is just that for formality and for the ease of the chemical reaction, we have written it in this inner type of ring form. Or this is 1, 2, 3, 4, 5, and 6 carbon atoms. Therefore, it would be N-hexane. N-hexane, it can be written as CH3, 1, 2, 3, 4, 4 times CH2, CH2 4 times, and then R CH3. Therefore, 4 carbon atom, 4, 5, and 6 means N-hexane. Now, this on reaction in the presence of a catalyst at high temperature. Now, the catalyst here. Now, the catalyst that we use is chromium oxide or aluminum oxide Al2O3 at high temperature 773 Kelvin. 773 Kelvin, there is removal of hydrogen gas. Therefore, we will be getting here CH2, 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 CH2. These joints here. Now, the example here, this can be written as. Now, how does this reaction occur? We can write that this CH2, this can be written as H2 and H. Now, one sigma bond is made up of 2 electrons. Therefore, 1 electron is donated here. Hydrogen, the bond breaks. There is homolytic cleavage. 1 bond breaks, and then removal of hydrogen gas. And therefore, there is a formation of this bond. Therefore, there is formation of this bond here. Thus, this shows that this is known as cyclohexane. Now, this is a cyclohexane molecule. Now, this on heating, there will be removal of 3 moles of hydrogen gas, and then we will be getting here our aromatic compound, that is our benzene ring. Therefore, in this way, the aromatization reaction of alkanes takes place. Now, let's check out the third chemical reaction of alkanes, that is reaction with steam. Now, in the reaction of alkanes with steam, methane molecule breaks with steam at 1273 Kelvin in the presence of nickel catalyst to form carbon monoxide and dihydrogen. Now, when alkanes react with steam, there is formation of carbon monoxide and dihydrogen gas. Now, the compound form is known as water gas. Now, the release of this carbon monoxide and dihydrogen is known as the compound. This compound is carbon monoxide and hydrogen gas. They are together known as water gas. Now, let's check out the chemical reaction. Methane. This is an alkane when it reacts with steam. In the presence of nickel catalyst on heating, there is release of carbon monoxide and water. Now, if you want to balance these chemical reactions, we have 4, 5, 6 hydrogen atoms. Therefore, 3, 2, or 6. Therefore, this is balanced now. Therefore, this is known as the water carbon monoxide and hydrogen on combination. This is known as water gas. Therefore, in this way, alkanes react with steam to give water gas. Thus, these are the 3 chemical reactions of alkanes. In the next video, we'll be studying the first unsaturated hydrocarbons, that is, are alkenes.